Now this is continuation from the division of indices. Now if we consider this setup, 5 to the power 6 divided by 5 to the power 4. Now we can write this as 5 to the power 6 over 5 to the power 4. It's like fraction form, division, so we write it as a fraction form. Now 5 to the power 6 is actually 5 multiplied by itself 6 times. 1, 2, 3, 4, 5. So it's 5 times 5 times 6 times. And 5 to the power 4 is 5 multiplied by itself 4 times. 1, 2, 3, 4. Okay. Now, so we have 6 5s in a row. There's 6 5s multiplied by themselves, and we have 4 5s on a row on the bottom multiplied by itself. The top is being multiplied, so the bottom is being multiplied into the top. Okay, now we cancel down in pairs, top and bottom. So this pair with this is one pair. We say 5 into 5 is 1. Another pair, 5 into 5 is 1. 5 into 5 is 1, and 5 into 5 is 1. So all this green, these 4 5s, they'll just cancel out, and the whole of this just becomes 1. So it becomes a 1 times this. So in effect you can ignore this. So you've cancelled out. Then what we're left with is 5 times 5. 5 times 5. Now 5 times 5 is 5 to the power 2. You can see a 2 here. Now if we look from the original equation, we have 6 and 4. Now 6 take away 4 is 2. This 2 is the same as this 2. So this is the second law of indices. When you're dividing the numbers, when you're dividing, you just take the powers away. So 6 minus 4 will give us 2. So this 2, so it will just be 5 to the power 2. Yeah, so this 2 is actually these 2 taken away, these 2 indices taken away. So 6 take away 4, which is 2. Now this is a general form, the general law of second indices. So it's a to the power m divided, so in this case we're dividing by a to the power n. That is equal to a, so the base stays the same, to the power m minus n, m minus n. Because we're dividing, we take away the indices. Okay, now, so we're going to use the second law to do some examples. So the second law stated again, a to the power m divided by a to the power n is equal to a to the power m minus n. So when you divide here, you take away the powers. So question 1, 4 to the power 5 divided by 4 to the power 2. So it's going to be 4 to the power of 5 minus 2. So it's 5 minus 2, which is 4 to the power 3. Okay. 2, t to the power 6 divided by t to the power 4. That is equal to, t is going to be the same, the base is going to be the same, it's going to be t. So it's going to be t to the power of 6 minus 4, which is 6 minus 4, which is t to the power 2. 6 minus 4 is 2, so it's t to the power 2. Okay, now we have a special case. We have this orange, yellow, 3 to the power 5 divided by red, 4 to the power 4. Now this 3 and this 4, they're different. So the bases are different, so you can't just add these powers. But what we can do, we could put 3 to the power 5 on top, divided by 4 to the power 4 on bottom, and all we do is 3 to the power 5, we just multiply 3 times 5 times, that's 243, and you divide it by 4 to the power 4, which is 4 multiplied by itself 4 times, and it's 256. So here the bases are different, this 3 and this 4, they're different. Here they're the same, it's 4 and 4, and it's t and t, so you can't simplify. So this last example, 5 to the power 4 divided by 5 to the power 3. So the bases are the same again here. It's 5, so we have 5 here is equal to 5. And the powers, when we're dividing, we're taking away. So it's 4 minus 3, which is 5 to the power 1. Now, anything, this is a special case. This is a special case. Anything to the power 1 is just itself. So 5 to the power 1 is just 5. This 5 has an invisible 1. But normally, in normal convention, we don't write it, we don't show it. So 5 to the power 1 is actually just 5. But for indices, you might need it.